Okay, we have the credit card class. How do we know that the name of this class is credit card? Because of this one. Okay, credit card. And we have 5 data members. What are they? We have 1, 2, 3, 4, 5. Okay, and there are 7 methods. So we have 1, 2, 3, 4, 5, 6, 7. Okay. And we learned that this is the constructor. We have 1, 2, 3, 4, 5. Okay, we have 5 data members, and we will define it in the constructor. And then we have the methods. 1, 2, 3, 4, 5, 6, 7. Okay. So in the code, we have a special name. This special name is to run the code. And because this is the special variable, when your module or code is imported by another, or when your code is the main program. So because last time we have this one, the credit card. We have the constructor, we have this function and so on, and then we have this one. What is this? This is the main function. So whenever we run this code, then Python will check the main function. This is the main function. If you learn Java, we have the main method. So this is the main function in Python. Okay, so this is the code that we already looked at. So now I'm going to teach you if I do not want to copy and paste the code. So I just use the existing code here. It means this is from the credit card.py. So can I run the code from here? Yes, it is possible. So you need to run the not compute. This is the exclamatory sign. And then you need to call the Python. And we need to call, where is this file? This file is located in the folder ch03. So you need to call the folder name. And then what is the file name? The file name is creditcard.py. And I can creditcard.py. So without copy and paste the code, we can just run the file creditcard.py, and you need to access the directory name. In this case, the directory name is ch03. And you need to run the Python command, and this Python command, you need to follow it with the exclamatory sign. So the result will be the same. Okay. Okay. Now we are going to discuss a little bit about the object-oriented design principle. When we learn about this OOP, or the object-oriented programming, we need to understand the design principles. So the first principle is modularity. The second principle is abstraction. The third principle is encapsulation. And there's another concept, we call it polymorphism, but maybe I will not discuss this more about the polymorphism. So the modularity. The modularity is the process of decomposing a problem or a program into a set of modules so as to reduce the overall complexity of the problem. So if I have, let's say, this is a smartphone. See? Your smartphone can have a lot of functions. Your smartphone can have a lot of application. So its application will be an independent program. And this is what we call as the modularity. One module, another module, third module, fourth module, fifth module, and so on. So if you have the idea about the object oriented, so you will make every single function as a module. That's the reason why we need to understand the OOP. Now, let's look at the median calculation. Do you know median? How can we calculate the median? Suppose I have number like this. Okay. What will be the step to calculate the median? So first, we need to sort the number. And then next, check if the total number in the sequence is odd or even. If the total of the element, if it is an odd number, you can just select the middle value. If the total number in the sequence is odd, then the median is the mid value. But if the total number in a sequence is even, then the median is the mean of the two middlemost numbers. For example, I have the numbers 2.7, 3.5, 5.1, 8.3. What is the median? The median will be the two middlemost numbers, because we have 1, 2, 3, 4. Because we have 4 numbers, so the median will be the element, the second element, and the third element divided by 2. So we have 4, 3 for the median. What about if we have this number? So we have 1, 2, 3, 4, 5. So the element is 5. So the median will be the middle number. Then we can get the median is 12. Now, means we will do several steps. In order to calculate the median, we need to do, the first step is to sort. Sorting, it can be in the module number 1. And then we can check whether the length or the number of elements in that list or tuple is odd or even. So we can use the odd even as the module number 2. So because we last time created the odd even.py. We can use that one as our modulation. If odd number, then select n plus 1 divided by 2. If even number, then select n divided by 2 plus n divided by 2 plus 1. So this is the median calculation. Or we can say this is the module number 2. So we can also think the modularity something like this one. So you can make 3 different functions. Okay. Abstraction. What is the meaning by abstraction? Abstraction means to focus to the essential features of an element or object in the OOP or object-oriented programming. And we ignore its extraneous or accidental properties. The essential features are relative to the context in which the object is being used. So we can see something like this. We have vehicle. Okay. The vehicle class, it means it is an abstract class because there are a lot of vehicles. We can say the SUV is a vehicle. We can say a sedan is a vehicle. We can say a truck is a vehicle. We can say a bus is also a vehicle. So we can create an abstract class vehicle. So what is vehicle? Vehicle is something that has wheel. Vehicle is something that has steer. Vehicle is something that has seat. Vehicle is something that has window. So we can define everything. If it is the general of the vehicle, we can put it into the abstract class. But if it is detailed or if it is more specific to the sedan, we can put that abstract. We can put that class in the sedan class. Okay. We call the abstract class for the vehicle. We call class for the specific. We can call the abstract method if it is the general method. We can have the specific method in every class. And there's another concept, we call it interface. But maybe you can just understand the abstract method and the abstract class. What we are going to use in our class, most are related to the abstract data type. So the abstraction is to distill a system into its fundamental parts. So when we deal with the abstraction, it means we are going to make this one. We are going to make the general data type. It means applying the abstraction paradigm to the design of data structures give rise to the ADT, abstract data types. An ADT is a model of data structure that specifies the types of data stored and the operation support on them and the types of parameters of the operation. So as I mentioned to you, a vehicle, it has window, it has wheel, it has steer, and so on. So later on, when we specify the abstract data type, we can specify something that are common. And if we want to apply it, then we can make something specific. So editing specifies what its operation does, but not how it does. So the collective set of behaviors supported by an entity is public interface. So we will learn what is the ADT and how we can make the public interface. Encapsulation. The encapsulation means it is the process of binding both attributes and methods together within a class. Through encapsulation, the internal details of a class can be hidden from outside. The class has methods that provide user interfaces by which the services provided by the class may be used. So later when we use the encapsulation, we will learn about what is the default method, what is the default data members, whether any data members are public or whether there is any method which is private, and whether there are some of the data members of the functions are protected. So those kind of concepts are from the encapsulation. So it also apply for the class or the interface to understand about the public, private, and private. And yeah, one example that we can learn from this kind of data structure is the iterators. If you learn iterators, it is one of the important concepts in the design of data structures. So if you understand the for loop is very important in every data structure. So the iterator for a collection provides one key behavior. It supports a special method named next. So we need to specify what is the next. And there are different kind of next. Next, it returns the next element of the collection, if any, or raises a stop iteration exception to indicate that there are no further elements. So if I have like list, let's say 1, 3, 2, 5. So I can have the element next. If now I'm in the first element, I can check, is there any next? Is there any next? Yes, okay, then I can go to the next. Is there any next? Yes, then I can go to the next. Is there any next? Yes, I can go to the next. Is there any next? No, then stop. When we use the range, it is the one developed in Python. We call it, this is the ultimate iterators. So when we define the range, we can specify the implementation of next in various ways. For example, we can define length. So how many items in a data structure in your data, and then whether you want to get the item or not. So in the class range, we can specify the constructor here. If you still remember, when we use range, there is a kind of numbers. It has start, it has stop, and it has stack. So if the step is 0, yeah, it is not possible. Because we want to go to the next, we want to go to the next, we want to go to the next. So the step will be always stuck with 1. If the stop is known, then we can say that the start will be 0 and the stop will be the start. And then we need to check what is the length? In this case, the length is the maximum of 0 or stop minus start plus step minus 1 divided by step. So it is the definition if you want to calculate based on the numbers in the element. And then we can define the variable start will be equal to the start, and then the variable step will be equal to the step. So length, we can specify this length according to this calculation. Get item, so I want to know which item that I need to select. It is based on the condition if k is 0. Sorry, if k is less than 0, then it will be added. So because the k cannot be 0, it should be impossible. If not 0 less than equal to k less than self.length, then it shows the index out of range. So that's the condition whenever you do the iteration. So you can look at the range. I give you the code range.py. So this class range is the same when you try to use the common range. For example, for I in range 0 until 10. So when we specify range 0 until 10, it is similar when we try to define that before. So maybe you want to say like R equals to range R equals to import ch03 dot range. Maybe I can say SR. So R, it is the range. Okay. So I can make R1 equals to R with 0, 10. Oh. R dot range. So I'm going to use R to call the file in the range, and then I'm creating a new object R1, and then this object will be based on the class range, and then I'm going to make the parameter or the argument from 0 until 10. Now I'm going to check if it is available. Print I. So R1 is an object from the range. It is similar with the range 0, 10. But I'm developing a new object. It is R1 from the class range. And this class range is from the range.p1. The object range is from this class. And when I created this object, I use this object as the element here to make the loop from I, which is in the R1. R1 is from 0 until 10. It means this is the number from 0 until 9. Okay. We have the term inheritance. Inheritance means it is a mechanism for a modular and hierarchical organization. So this allows a new class to be defined based upon an existing class as the starting point. So the existing class is typically described as the base class or the parent class or superclass, while the newly defined class is known as the subclass or child class. So if the class is in the higher position, we call it, this is the base class or parent class or superclass, and it can have another class which is the subclass or child class. There are two ways in which a subclass can differentiate itself from its superclass. So a subclass may specialize an existing behavior by providing a new implementation that overrides an existing method. A subclass may also extend its superclass by providing brand new methods. Okay, what does it mean by this? Let's see. In Python, we have the base exception. Exception is for the error message. For any error message, it will go to the exception class. And then this base exception, it can be distinguished into another subclass. This is another subclass, system exit. It is another subclass, exception. It is another subclass, keyboard interrupt. So for this subclass, it is the superclass of this class. So the value error is the subclass of exception. Lookup error is the subclass of this exception. Arithmetic error is the subclass of exception. Again, this is the superclass of this class. So it means it can be inherited, or it can be in the kind of structure. The higher is the superclass, the lower is the subclass. The higher is the parent, and the lower is the child. Now, let's make something related to the student. In the student, I have one class, and let's say there are several kind of students. Maybe in this school, we have the undergraduate student, and graduate student, they have concept. So they are different. But most of the information are the same. For example, the student name. All students will have name. All students will have address. All students will have score. But the difference is how many credits that you need to take. That actual. Okay? For the undergraduate student, you need to take maybe 100, more than 100 credits. For the graduate students, you need to take maybe only 30 credits. So that's the difference. So we can say that the class student is the superclass, and we can make subclass. The subclass is the undergraduate student and the graduate student. Now, let's see how we can make this kind of OOP problem. If you look at this, how many data members do we have? Yeah, 3 data members. And how many methods do we have? Yeah, 4. Okay. Now let's try to make this one into the Python. Okay, let me make class student. So in this class student, we have 3 data members. So you can define the constructor. The constructor means self. Okay, that will be the first that you need to define. And then I have the student name. I have the student city. Okay. Let me consider the score later. So I can define the self.stu name. Maybe, yeah, it depends. If you want to put the underbar, it's also fine. If you want just the same as the parameter, that's also fine. Let's say this is the name, and then I have the stu city. It is the stu city, and then let's say I have the score equals to 0. So I have 3 data members. Now I need to define the functions that I have in this class diagram. So I have the def get stu name, and then I need to define the self. So I will get the self dot underbar stu name. Return self student. I need to get the student city self. So I need to return self dot underbar stu city. I need to make no function get stu score self score return self score. And then I can make a new function set student score. I have self, and then I have the score. So it will set the score self dot score equals to the score. So we have 4 functions: get student name, get student city, get student score, get set student score. And we have 1 parameter, which is the score here. So I specify here. Okay, I hope that you already know how to make this kind of code. So next, I have a new class, which is graduate student. So this graduate student class, you can see there's an arrow. Okay. What does it mean by this arrow? This arrow, it means it is inherit. Inherit means the graduate student class will have most of the properties from student. Okay. The graduate student can use the student name, can use the student city, can use all the function here, but there will be a new defined function that is the get maximum credit, and there will be a new data member which is maximum credit. So I can define like this one. I will make a new class, graduate student, and I need to specify what the class will inherit. Because this graduate student will inherit from the class student, so I need to say that this graduate student will inherit from the class student. Okay. After I know that it will inherit from the class student, so whenever I define the init, I will define based on the same of the student. That is, I have the student name, I have the student city, but now when I try to create a new student, I will call the super. I will call the super class. And the super class that I want to access is the init, that is the two parameters that I have in the super class. So the two parameters are student name and the student name. And then I will define the self dot maximum credit equals to 30. So the graduate student will have all information from the super class, which is the student name, student city, and score. And there will be an additional data member, which is maximum credit. And I need to define one more function, which is the get maximum credit. So I have the definition of get maximum credit. I need to define the self, and then it should return the self the maximum credit. Okay. Now let me run. Let's say I have student one. Student one is using the class student. Let's say I use the student one is, okay, let me just use my name. And then I live in Yongin City. So S1, I can get the student name. So the name is variable. S1, I can get the student city. The city name is Yogi. S1, I can get the student score. The score is 0. Now, my question, can I get the maximum credit? Get maximum credit? No, because it is only in the class of student. Okay. Now, let me have another object. I have G1. Okay. So, G1 is the graduate student. This is the graduate student. And I need also to define name and the city. So let's say I have another student, name is Yahya. And then he lives also in Yongin. So G1 is a new graduate student. So I want to know his name. Can I get his name? Oh yes, I can get his name. His name is Yahya. Can I get his city? Yes, I can get his city. It is Yongin. Can I get his score? Yes, I can get his score is 0. Now, can I get his maximum credit? Yes. I can get his maximum credit because he is a graduate student. Okay. If your object is based on the class student, then you cannot make any object and you cannot access the graduate student because it is different class. If you make a graduate student object, you can access all these classes together with all this function and this data member because the graduate student inherit anything from the student. Okay. Okay, so this is the explanation. If you are creating the instances of student, if you just create the student, then yeah, it just have the information about the student. But if you create an instance of graduate student, then you can access the information about the maximum credit and you can access any function in the graduate student. But if it is a student, then you cannot access this one. Okay. Okay, I think I need more time to explain this one. So let me stop and